ASNT Level 2. Liquid Penetrant Testing Level 2. General Examination. Note down your answers in notebook and verify with my answers at the end of video. Liquid penetrant testing, also known as penetrant testing or dye penetrant inspection, is a widely used non-destructive testing method for detecting surface-breaking defects in various materials. It involves applying a visible or fluorescent dye to the surface of a component, which then penetrates into any discontinuities through capillary action. In this guide, we will explore the responsibilities and training requirements for individuals certified to Penetrant Level 2, as well as the examination process and certification options. To become certified as a Penetrant Level 2 technician, comprehensive training is required. Lavender International offers Penetrant Level 2 training courses that cover both general and specific theory related to the method. Question point 1. A common application of an aluminium block containing quench cracks is to determine penetrant test sensitivity. Compare performance of penetrant materials or processes. Determine effects of mechanical cleaning methods on penetrant test results. Determine effectiveness of cleaning techniques. Question point 2. Which of the following is not an advantage of a water-washable fluorescent penetrant process? Excess penetrant is easily removed with a water wash. It is well suited to testing large quantities of small parts. It is readily removed from shallow discontinuities. It has low cost, low processing time compared to the post-emulsified penetrant process. Question point 3. When using a water-washable penetrant testing process, why should the water rinse temperature remain constant? To avoid changes in rinse efficiency. To maintain the temperature of the part. To avoid overwashing. To avoid underwashing. Question point 4. What is the proper technique for removal of excess penetrant from a part when using a water-washable penetrant process? Fine spray normal to the surface. Coarse spray normal to the surface. Fine spray at 45 degrees to the surface. Coarse spray at 45 degrees to the surface. Question point 5. Which type of developer would you use to obtain the highest sensitivity test results? Dry. Non-aqueous wet. Aqueous wet. Lipophilic. Question point 6. What type of penetrant process would be best suited to an application at near freezing temperatures? Solvent removable. Water washable. Post-emulsifiable. None of the above. Question point 7. Which type of developer does not provide a contrasting background against which to view penetrant indications? Dry. Non-aqueous wet. Water soluble. Water suspendable. Question point 8. Which type of developer should not be used with a visible dye penetrant process? Dry. Non-aqueous wet. Water soluble. Water suspendable. Question point 9. Why might steel parts have a greater tendency towards rusting after penetrant testing? Penetrant materials are normally corrosive. Penetrant materials residues are hygroscopic. Any protective oils are removed during penetrant testing. This is true only if the developer and penetrant residues are not removed after testing. Question point 10. The most significant advantage of the visible solvent removable penetrant process is its suitability for penetrant testing of article with rough surfaces. Portability. Its non-corrosive properties. Ability to allow retest. Question point 11. Correct developer coating thickness is indicated by an even, snowy white appearance. A slightly pinkish background. A fine, misting spray. A thin, translucent layer. Question point 12. Which penetrant test processes commonly use the same penetrants? Water washable. Water washable and solvent removable. Solvent removable and post-emulsifier. None of the above. Question point 13. Mercury vapor black lights may be extinguished if the supply voltage drops below about 120 volts, 90 volts, 220 volts, 200 volts. Question point 14. The output of a mercury vapor black light depends on cleanliness of its filter. Age of the bulb. Both A and B. None of the above. Question point 15. When a mercury vapor black light is first turned on, what minimum warm-up time is normally required? None. 2 to 3 minutes. 5 minutes. 10 minutes. Question point 16. When a mercury vapor black light is inadvertently cut off, approximately how long should it be allowed to cool before attempting to restart? Not required. 2 to 3 minutes. 5 minutes. 10 minutes. Question point 17. A soft aluminium test piece is to be penetrant tested. The piece has previously been sand-blasted to remove tightly adhering soils. What additional surface preparation should be performed? Etching. Solvent cleaning. Ultrasonic cleaning. Grinding. Question point 18. Dried, non-aqueous developers are best removed after penetrant testing by solvent cleaning. Wiping with a water-dampened cloth. Wiping with a dry towel. Any of the above. Question point 19. The most important penetrant test processing time to control is penetrant dwell time, emulsifier dwell time, water rinse time, development time. Question point 20. A penetrant which contains an emulsifier is called solvent removable, water washable, post-emulsifiable, solvent suspended. Question point 21. A penetrant which requires a separate emulsification step prior to removal from the surface of the test piece is called solvent removable, water washable, post-emulsifiable, solvent suspended. Question point 22. The chief advantage of using a water washable penetrant process is sensitivity, safety, water tolerance, economics. Question point 23. While performing a fluorescent water washable penetrant test, which of the following steps should be performed under black light? Penetrant application, excess penetrant removal, emulsification, developer application. Question point 24. What are the two most important properties in determining the penetrating ability of a penetrant? Viscosity and surface tension. Viscosity and contact angle. Surface tension and wetting ability. None of the above. Question point 25. The human eye is most sensitive to which of the following types of light? Yellow-green, red, blue-violet, orange. Question point 26. What amount of time is normally considered necessary for dark adaptation of the eyes prior to performing a fluorescent penetrant test? None required. 1 to 2 minutes. 3 to 5 minutes. 5 to 10 minutes. Question point 27. Which of the following is not normally recommended? Performing a fluorescent penetrant test following a visible penetrant test. Performing a visible penetrant test following a fluorescent test. Removing excess penetrant with a water spray. Removing excess penetrant with towels moistened with solvent. Question point 28. What is the most common source of penetrant bath contamination? Emulsifier, water, developer, solvent. Question point 29. Which of the following is normally considered acceptable practice? Sandblasting a soft aluminium part during pre-cleaning. Performing a fluorescent penetrant test following a visible penetrant test. Performing a retest on a part tested with a water-washable penetrant process. Removing excess penetrant with a water spray. Question point 30. A penetrant testing method in which an emulsifier, separate from the penetrant, is used is called solvent removable, water washable, post-emulsifying, self-emulsifying. Question point 31. A penetrant testing method in which the degree of washability can be controlled by the operator is called self-emulsifying, post-emulsifiable, water washable, solvent removable. Question point 32. Open, shallow discontinuities are best detected by which penetrant testing method? Solvent removable, water washable, post-emulsifiable. None of the above. Question point 33. An advantage of the post-emulsifiable penetrant testing process is that test pieces can be reprocessed several times with little loss of sensitivity. It is the most economical penetrant testing process. It is highly susceptible to overwashing. It is not self-emulsifying. Question point 34. A disadvantage of the post-emulsifiable penetrant process is that test pieces can be reprocessed several times with little loss of sensitivity. It is not very sensitive to open, shallow discontinuities. It is less sensitive to degradation in the presence of acids and chromates. Emulsifier application is an extra processing step. Question point 35. Acceptable methods to apply emulsifier are dipping, flowing, spraying. All of the above. Question point 36. An advantage of emulsifier application by dipping is, excess penetrant is recovered in the emulsifier tank and reprocessed. All of the test object is coated at approximately the same time. Excess emulsifier drains back into the emulsifier tank for reuse. Hydrophilic scrubbing is then easier to perform. Question point 37. Emulsification time is less critical for the detection of fine, tight cracks, wide, shallow discontinuities, internal porosity. None of the above. Question point 38. Overwashing during excess penetrant removal is less likely with which penetrant testing process? Solvent removable, water washable, post-emulsifiable, self-emulsifying. Question point 39. The fluorescent dyes used in the liquid penetrant testing process are most active when energized with black light of what wavelengths? 2.0 x 10 m, 2.5 x 10 m, 3.25 x 10 degree m, 3.65 x 10 degree m. Question point 40. Application of penetrant to a test piece may be by dipping, brushing or spraying. Spraying only. Bushing or spraying only. Dipping or spraying only. Question point 41. The penetrant process best suited to use on parts with rough surfaces is solvent removable, water washable, post-emulsifiable, magnetic particle. Question point 42. The penetrant process best suited for the detection of very fine discontinuities is solvent removable, water washable, post-emulsifiable, magnetic particle. Question point 43. The penetrant process best suited for use on parts with keyways and threads is solvent removable, water washable, post-emulsifiable. None of the above. Question point 44. Indications which are caused by design or construction of the test piece are called relevant, non-relevant, false, real. Question point 45. Indications which are caused by something other than a discontinuity are called relevant, non-relevant, false, real. Question point 46. Which of the following discontinuities would you not expect to find in a casting? Shrinkage cracks, incomplete penetration, cold shuts, porosity. Question point 47. Which type of casting is made in a metal mold? Investment casting, sand casting, die casting, lost wax process. Question point 48. The act of determining the cause of an indication is called interpretation, inspection, evaluation, determination. Question point 49. The act of determining the effect of a discontinuity of the usefulness of a part is called interpretation, inspection, evaluation, determination. Question point 50. Contaminants which are commonly limited in penetrant materials are hydrogen and chlorine, carbon and sulfur, hydrogen and carbon, chlorine and sulfur. Please check all your answers. Thank you for watching. Keep supporting. Thank you for watching.